The components that make up a digital computer system can be split into two groups: hardware and software. Computer software, or just software, is a general term used for digitally stored data such as programs of instructions read and written by computers. Hardware is the name given to the collection of mechanical, magnetic, electronic and electrical components making up a computer system. In this lesson, we will examine both hardware and software. And we will look at the regulations that are in place to ensure safety is not compromised when computers are used in aircraft systems. All computers have the basic hardware components shown in this diagram. This design is known as von Neumann architecture. It is named after its designer, the mathematician and early computer scientist John von Neumann. We will now describe each of the components in turn. The Central Processing Unit, or CPU, performs, organizes and controls all of the operations the computer can carry out. It is really the brain of the computer. The CPU consists of a number of individual components. The Arithmetic Logic Unit, or ALU, performs arithmetic calculations and logic operations using the binary number system. The shift registers are temporary stores. One of them, called the accumulator, contains the data actually being processed. The control unit contains the computer's clock. This is a crystal-controlled oscillator which generates timing pulses at a fixed frequency in order to synchronize the computer's operations. The CPU accepts digital signals from the input peripheral devices via its input port. In the case of a personal computer or PC, these may be the keyboard, the mouse, or any other input device. In an aircraft, the inputs could be from various sensors: radio altitude, barometric altitude, airspeed, fuel flow, and so on. After processing, the computer's output is fed out via its output port. In the case of a PC, the output peripheral may be a visual display unit, monitor, or printer. In an aircraft, the output may, for instance, be fed to an electronic flight instrument system or EFIS symbol generator, or to the flight management system control display unit. A computer needs a working memory to run the program of software it has to execute. To do this, a read-only memory or ROM device is used. ROM is programmed by the computer manufacturer. It cannot normally be altered by the user. It is usually contained on an electronic chip with no moving parts. Memory that retains data when the power is switched off is called non-volatile memory. ROM data is contained in non-volatile memory. Electronically alterable read-only memory, or EAROM, is a special type of ROM that can be electronically altered. This type of memory is used to hold the database of an aircraft's flight management system computer. The computer contains a worldwide database of all airfields, navigation aids, airways, and so on. Periodically, this data changes and the database needs to be updated. This is achieved on a 28-day cycle when a company, such as Jeppesen, contracted by the airline, issues an updated software program. This program is loaded into the FMS by a technician, overwriting the old data in the EAROM with the new. If a program has to be changed during operation, then the memory must be able to be written to as well as read. To do this, random access memory, or RAM, needs to be used as well as read-only memory. With this type of memory, data can be written in, read out, and altered at will. RAM is also required to store the data for processing, as this also will change continually. Memory that loses data in the event of a power failure or switch off is called volatile memory. RAM is normally volatile memory, so any data stored in it is lost in the event that the power is removed. Buses or bus bars are used to connect the CPU to the computer's memory and to the peripheral equipment. A control bus is used by CPUs for communicating with other devices within the computer and with peripheral devices. The control bus carries commands from the CPU and returns status signals from the devices, while the address bus carries the information on which device the CPU is communicating with, and the data bus carries the actual data being processed. Digital computers use digital or binary information, but many aircraft sensors produce analog information in the form of varying voltages, pressures, temperatures, and so on. A component known as an analog to digital or A to D converter is required to allow the computer to read this data. When a digital computer has to pass information to an analog device, the process is reversed and a digital to analog or D to A converter is used. One computer which uses such a system is the central air data computer. This computer takes in static and dynamic air pressure and outside air temperature signals and produces outputs for instruments such as the Mach meter and the true airspeed indicator. In computing, multitasking is a method by which multiple tasks share common processing resources. In the case of a computer with a single CPU, the CPU can only actively execute instructions for one task at a time. Multitasking solves this problem by scheduling which task may be the one running at any given time, and when another waiting task gets a turn. The act of reassigning a CPU from one task to another one is called a context switch. When context switches occur frequently enough, the illusion of parallelism or of actions happening simultaneously is achieved. Multiprocessing is the use of two or more central processing units or CPUs within a single computer system. This type of computer can genuinely complete a number of tasks simultaneously. An operating system, or OS, is a set of system software running on a computer that manages the system hardware and controls the execution of application software. You will no doubt have heard of the Microsoft Windows operating system used on many personal computers. An example of an operating system used in aircraft computer systems is the Lynx operating system, supplied by the Linux Works Corporation, which is used in the Airbus Air Traffic Services Unit, ATSU, computer. This computer integrates all services dedicated to data communication between the aircraft and the air traffic centres, as well as the Aircraft Communication Addressing and Reporting System, or ACARS, functions. Permanent storage for computer programs and the work they generate is provided by storage peripherals. These can take the form of magnetic disks, optical disks, or solid-state electronic chip devices. The storage capacity of these devices is measured in units of bytes, normally megabytes or gigabytes. 1 megabyte is approximately 1 million bytes, and 1 gigabyte approximately 1,000 million bytes. There are two types of magnetic disk systems in common use. Hard disk drives are usually magnetic disk drives, with the disk being an integral, non-removable part of the unit. Floppy disks are also magnetic disks. These and optical discs, such as compact discs or CDs, and digital versatile discs or DVDs, can be inserted and removed from drives, making the data they contain transportable and securable. Data can also be held on solid-state electronic chip devices using a method known as flash memory. Again, these devices can be removed from the computer. A programming language is a language used by a computer programmer to write computer programs. There are a number of languages in use. Here we will define three of the most common types. Assembly languages use a symbolic representation of the binary codes and other constants needed to program a particular central processing unit. This representation is usually defined by the CPU manufacturer and is based on abbreviations, called mnemonics, that help the programmer remember individual instructions. A particular assembly language is thus specific to its related CPU. A high-level programming language is a programming language with strong abstraction from the details of the computer. Many normal words are used during programming. In comparison to assembly language, it is easier for the programmer to use and is more portable across different types of computer. A scripting language is a programming language that allows control of one or more software applications. Scripts are distinct from the core code of the application, as they are usually written in a different language and are often created or at least modified by the end user. Aircraft systems which are computer controlled include the Flight Management System, FMS, the Digital Flight Guidance System, DFGS, the Ground Proximity Warning System, GPWS, the Traffic Alert Collision Avoidance System, TCAS, and an increasing number of other systems. Operation of these systems is explained in the relevant lesson. Current design favours the use of a dedicated computer for each separate system. In the future, however, we may see sharing of computer power in the form of an Integrated Hazard Warning System, IHWS. Here, a powerful central processor with appropriate backup handles inputs from the stall warning system, wind shear detection, GPWS, TCAS and the weather radar, processes the information and prioritizes warnings to the crew. Fly-by-wire aircraft take computer control very much further, when the whole flight envelope is controlled by computer processors with inputs from the crew when necessary. Where computers are used to control safety-critical pieces of aircraft equipment, it is essential that the software is exhaustively tested to ensure that there are no bugs in it, which could lead to failure of the equipment. The regulations governing this testing and the acceptable failure rates of software are contained in the document Euro-CAE ED12B, titled Software Considerations in Airborne Systems and Equipment Certification, issued by the European Organisation for Civil Aviation Equipment. That is the end of the lesson. Here is a summary of the main points. Computer software is a general term used for digitally stored data, such as programs of instructions read from and written to by computers. Hardware is the name given to the collection of mechanical, magnetic, electronic and electrical components making up a computer system. A basic digital computer consists of a number of components joined together in a design known as von Neumann architecture. The central processing unit, or CPU, performs, organizes and controls all the operations the computer can carry out. Within the CPU, the arithmetic logic unit, or ALU, performs arithmetic calculations and logic operations using the binary number system. The shift registers are temporary stores of data and the control unit contains the computer's clock. Computer memory that retains data when the power is switched off is called non-volatile memory. Memory that loses data in the event of a power failure or switch off is called volatile memory. Read-only memory, or ROM, is non-volatile memory. Electronically alterable read-only memory, or EA-ROM, is a special type of non-volatile ROM that can be electronically altered. Random access memory, or RAM, is normally volatile memory. Buses or bus bars are used to connect the CPU to the computer's memory and to the peripheral equipment. A component known as an analog to digital or A to D converter is required to allow the computer to read analog data. A digital to analog or D to A converter is used to pass a computer's output to an analog device. Multitasking is a method by which multiple tasks share common processing resources. Multiprocessing is the use of two or more CPUs within a single computer system. An operating system, or OS, is a set of system software that manages the system hardware and controls the execution of application software. Permanent storage for computer programs and the work they generate can take the form of magnetic disks, optical disks, or solid-state electronic chip devices. A programming language is a language used to write computer programs. Assembly languages use a symbolic representation of the binary codes and other constants needed to program a particular CPU. A high-level programming language is a language with strong abstraction from the details of the computer. A scripting language allows control of one or more software applications. Aircraft systems which are computer-controlled include the Flight Management System, FMS, the Digital Flight Guidance System, DFGS, the Ground Proximity Warning System, GPWS, the Traffic Alert Collision Avoidance System, TCAS, and an increasing number of other systems. The regulations governing the testing and the acceptable failure rates of computer software used in aeroplanes are contained in the document EuroCAE ED12B, titled Software Considerations in Airborne Systems and Equipment Certification, issued by the European Organisation for Civil Aviation Equipment.